And we will share main screen here. Okay, so what we need to do before we get started here is we need to make a new shared document for this class. So let's go and do that really quick. Not exactly sure that's the way to do that. Let's try this. There we go. Let's do make a copy. There we go. And let's open this one up. So this is going to be now the spring 2021 engineering shared document, and we'll link that in our thing here. Second. Just as a reminder, the shared document is this thing that you will add a kind of a tip or a trick to every week when you have an assignment due. Towards the end of the year, we won't have to do it because we won't have assignments. We'll just be working on a project towards the end of the year. But at the beginning, you're pretty much going to do it every week. And here are the examples that you can follow: your name, the date, if it's a tip or a trick or a shortcut or a function or whatever. I've got one of each: a tip, trick, a shortcut, and a function for examples. So I will go ahead and make this available on the web and then put the link in into my open math for you. So let's see, engineering 20, go into, I have to do it in each individual chapter, I think. So I'll do it here first. Shared document. Where did it go? This is being dumb. Let's do it this. No, this is actually the way it has to be. I don't remember. So let me go to this. Edit code. Delete. Paste. Save. Okay. Preview. Student preview. Yep. There we go. I need to get a better way to do this, but that's the best I can do it at the moment. So when you open up your shared document, let me show you what this will look like here really quick. 2, 3, 4. I have a computer for you, and I was right. The guy over on North Campus, his brother runs Walmart, and he's looking into it for us. So we should be able to get that accomplished, hopefully. This is the computer. This is in my old camera case. This is my old computer case. I'm totally flash. But it's in there with the cord if you want to use it while you're waiting. And you should be able to just open up and log onto the student account without a password. And MATLAB's already open on it, so you can use that whenever you want. All right. Everybody's got a computer then, right? So, and did everybody get MATLAB loaded? Any troubles with that at all? No? I did hear that somebody was saying that if you don't put in your school email, it gives you a lot of trouble. So make sure you put your school email when you're ordering that. So anyway, now that if you get into your into your first assignment for chapter 2 here, which is apparently due today. Doesn't really matter. Due dates don't matter much. But anyway, for chapter 2, you will you'll jump into the shared document question here, and you'll see, here we go. So then to get to the shared document, you click on the read button. It says right here, click on read button to access the document online. It's a little bit awkward, but I'm still trying to figure out a better way to do this so that you can just click on a link. The reason that I have to do it this way is because this way allows me to give you a score for this. But you'll click on this, and you'll go ahead and insert yours into this document, your particular tip or trick or whatever. And you don't have to press save or anything in Google Docs. You can just close it when you're done, and it's good to go. Then I'll go in and check that and give you your score each week. And I have a tendency to kind of get behind on grading in this class, just because there's the only thing more boring to me than actually writing code is reading somebody else's code. So as you're sitting there thinking, "Oh, I hate writing code," clickety clickety click, you can think of me like a week later going, "Oh, I hate reading code," and then maybe it'll make you feel better. Maybe not. So. What's that? It's not linking to it? That's no good. It shows the old one still?
It shows for chapter 3, but for chapter 3 there is no sharing one.
Huh. That's weird. Okay, let me try it again. Chapter 2. Oh, because it's not available anymore. Sorry. Let me fix something again here really quick. I have to go back and fix all of the dates here. So 120. So next week would be 127. And so I'm just going to change all the due dates here really quick. $127. There we go. So that should work now. Is it there now?
Yeah.
Okay. So now when you click on chapter 2 shared document, you should get this, and you should be able to click here, and it should take you to the new spring 2021 document. And that should work, I think, for all of them. Let me check to see if that went into chapter 3 as well. I might have to do each one by hand, but hopefully not. Chapter 3, shared document. Click on the read button. It takes you to the right one. So we're good. All right, that works. And if anything else goofy comes up in my open math, just send me a quick message, because this is all teacher supported. So I do my own code for this website, and I have to update it all the time. There's no guy paid somewhere in India doing all my stuff for me. So there's a lot of mistakes made just because I'm not an expert programmer and it's not my full-time job. I wish there was some great programmer in India doing this for me. And for my other class, I do have that, because I had to use a paid online program. But for this one, I just got to do it all myself. So just be patient. There is a bit of there are some quirks and things with this, but it's free, so we like that part. It also doesn't crash very often. I've only had this. My open math has only crashed worldwide maybe twice in 10 years, and all the other ones that I know crash just about every year, at least a couple of times. So that's another good thing about it. All right. There's something else I needed to do before we got started. What did I just do? And I don't remember what it is, but maybe it will come to me eventually. Oh well, we'll just have to live with that. There is one thing that I do want to show you just for fun, because I think it's funny. So I'm in this programming class for UNL, this graduate course that I'm taking, and this is what we learned in that class. This is kind of see if I can find it. Oh man, where did it go? Don't tell me I won't be able to find this video because it's such a great video. It was connected to this one because I think these guys, yeah, these guys are, this is the same guy, or maybe they're related to each other somehow. Man, I can't. I didn't save the, so this is the guy right here actually. He did this funny short video about um, what people think programmers do, and if I can find, where is the stupid video? Oh, here we go. Yeah, this is the one. So here he's searching the internet.
And paste. Let's go.
So that particular website called Stack Overflow is kind of like the Google for programming languages, and everybody uploads their code to there, and everybody asks questions there, and it's like this huge community where people say, "How do you do this? I can't make this work." And then somewhere in the world, there's like this group of super voodoo like gurus on every programming language, and they have every answer. And of course, that's just everywhere. But all these people that spend all their time in like some cave somewhere programming all the time, and they know the answer to everything, and they post this stuff up there. And that's been this whole class I've been taking. We just like tried something, it's totally bombed, and we're like, forget it. We just start searching the internet. Oh, somebody did it right here. We just copy that code right in there, and we're like, yeah, sweet. We have no idea what the code does really. We just know that it works, and we're good. So anyway, I didn't just show you that because I thought it was funny and I'm kind of a nerd. I showed you that also because this is actually an important part of programming, is getting used to looking up answers using the internet. Stack Overflow is a great website for that. There are dozens of others. Stack Overflow has a tendency to be very Python related, but it also does all kinds of other languages. Um, and of course, you can actually go directly to MathWorks, and they have a huge community on MathWorks for MATLAB. Uh, it, I don't know if I showed you that one, but the MathWorks, the MathWorks.com website, which is where you got your thing. If you go up here to community, this is a place where you can put in questions, you can search for different solutions, you can read through the latest stuff that people have been putting out there, and they have tutorials with videos and all kinds of stuff. So very useful when you're trying to figure out something in MATLAB. For the most part, in this class, we won't use this right away because almost everything that you're going to do is something that I'll be able to help you with because I have that understanding of MATLAB, or it's something you'll be able to figure out on your own because it's pretty basic. But once we get into like the last third of the class and you're working on a project, you guys are going to be trying out things that I've never done before. There's an infinite number of things you can do with programming, and I certainly have not done them all. I am not a programming expert. I don't really even like programming. It's just not thing that I can really wrap my head around. I don't understand sitting in a chair all day and just staring at a screen. It like makes me crazy. Um, but I can't even play video games, if that tells you how bad I am at staring at screens. Like when I was a kid, I grew up with video games. Like the Atari 2600 came out in 1980, and I was in kindergarten. So I grew up with all of the video games, with ColecoVision, which probably none of you have heard of, and I mean 50 others that nobody's ever heard of. And then going to video arcades, that was part of my life growing up, which is pretty rare these days. And I saw Nintendo become a company, and I saw all this stuff, and I can't play them. I try and I get frustrated. I'm always going backwards on the track when everybody's going forwards, and I'm always stuck somewhere when I can't get out, and I'm just terrible. And I can't spend the time staring at a screen to get good at these. And the sports ones today's I'm terrible at. Like I can't even figure out which guy I am on the field. And then somebody says, "Well, you're every guy on that team," and I'm like, "How can that be? I don't know what I'm doing." So my team ends up like scoring a touchdown on a basketball court, and I'm like, how does anybody do that? Anyway, I'm terrible at video games, so I'm even worse at programming. But I am here to teach you the little that I do know. And one of the things that I know is that when you don't know something, the internet's a great place to try and figure it out. Okay, now that we're done with that, let's actually talk about MATLAB. So we're going to go ahead and use this textbook. We will pretty much, for the first several chapters, just kind of go through this textbook kind of page by page, learning things that they learn here. From time to time, I'll kind of push it aside and we'll go learn something kind of off on our own. We might go look something up or watch a little video here and there. But this is actually a really good book. It's really well written. It's easy to understand. There's not a lot of mumbo jumbo in there that you have to interpret. It's not really, really bad to read like math books or something. So it's actually a decent book. Was anybody not able to pick up a copy yet? Your coach is working on it? Okay. Anybody else? You good? Okay, I can loan you guys a copy. I can loan you guys this copy for now. And if going forward we're still having a problem, we can make copies of individual chapters, problems, and things like that. Is it okay if I loan you two this copy and you guys just kind of pass it back and forth when you need it? I'm assuming you'll see each other quite a bit. So, all right. I would loan you, I have another copy. I'd loan you both copies if you promise to bring it back to class because I need it in class. But I did that one year and both students kept forgetting to bring it back to class. And then I was like, okay, I can't remember what's in that chapter, and I had to kind of wing it. What's that? One book is fine? Okay. All right, sounds good. Okay, so let's go ahead and we're going to start off. Sometimes I used to kind of like project the book up on the screen, but I don't think that's necessary. If you have it, you can kind of follow along. The most important thing is that you open up a computer and start doing the stuff that we're going to be doing in MATLAB together. Dang it. That's much more important than actually seeing the book up on the screen. So I'm going to close things out here a little bit, get away from all this junk. And I'm going to open up MATLAB, which hopefully downloaded properly. There it is. All right. So, I'm going to start off by opening up a new script. Because when you're doing your participation scripts, you need to open up a new script so you can save things. Students have a tendency to do this one of two ways. Some students will just type everything into this editor and just make a running like line after line of things that I type in during the class. Other students will write things in the command window and see if they work, and then they'll just copy that really quick and drop it into the editor. Both of those methods have their drawbacks. If you just type things into the editor, then you're not seeing how they work. You're not actually running the code all the time. And so that has a downside. But if you want to do it that way, you can. You just have to, you should run it every once in a while to see if it's working. So let's say, for example, the first thing we do is we assign a variable I'll call it Jared with a capital J. Jared equals 46 because I turned 46 a while ago. And that's my first line of code. And then I write in, let's say LeBron. I was just looking up LeBron James's age. Does he have a capital B or I can't remember. I just looked up LeBron's age because I knew he was younger than me, but I didn't remember how much younger. Turns out LeBron is 36, so he's 10 years younger than me. But then now I want to know if it's going to, if this is going to work, if MATLAB is going to read this and it's going to do what I think it's going to do, right? So I run that really quick, and I haven't titled it, so I'm going to call this assignment 1, or I'm going to call it chapter. You remember when you're naming scripts, you have to start it with a letter. You can't start with a number. You can't have any spaces, and you can't have any. You can't have. Well, you can have things like question marks, I believe, and I think you can put in numbers or hashtags or whatever, and dollar signs and percent signs, but you can't put in any periods, and you can't put in any slashes, and you can't put in any. I don't think you can put in any dash, but you can put in an underscore. So I could do this like chapter 2, like that, or I could just leave it as chapter 2. Either way, I don't think you can do chapter 2 like that. I don't think MATLAB allows that, but you can do chapter underscore 2 like that. So I'm going to go ahead and save that, and maybe I want to make a folder for saving it. So maybe I make a new folder and I call these my participation files or something like this. You can do that if you want to or whatever. Put it in that participation files thing. If you do this, MATLAB is going to come up with this little window. It's going to say, do you want to change your path to where you just saved this thing to? And what that means is that MATLAB is always looking for what you're doing on the computer. It's looking for where you've stored things. The path that you're in is where you stored things for your current project. So you probably do want to change to that folder for your path if that's where you've just saved this assignment. Because anything else that you save, if you save any variables or you save any plots, they will be saved there. And if you have any data that you need to pull in, it would be there as well. So it's a good idea to do that. And then it shows right here where that current path is. Your current folder right now is, and it shows it up here too. It's under users, Jared Daily, documents, MATLAB, participation files. And this is what is in that folder, my chapter2.m. So now that that's saved, I can go ahead and run it, and it does run it because I already told it to run. And it works. It prints out Jared equals 46, LeBron equals 36. You can see that over here, we have those two variables in our workspace. The workspace is the place on the RAM where it has saved variables for what you're doing right now. So now it knows that if I type in LeBron, oops, I have to spell, if I type in LeBron with all lowercase, it doesn't recognize it. But it does recognize that you have something like that. And I did mean LeBron, so I go ahead and press enter again, and it's saved there. And if I type in Jared, it knows that Jared equals 46. And I can even do something like Jared minus LeBron, right? Which tells you how old I was when LeBron James was born. I was in 4th grade. So that's just kind of some quick things to think about as you're doing this. Maybe you write it in here first and then you run it every once in a while. Or maybe you come down here and you write your code one line at a time. Let's say I want to make a new one with lowercase Jared equals, so lowercase Jared is going to be how old I was last year. I was 45, right? So I can type that in, and then I can say, well, that worked. So I would copy this code right here, just this, don't copy the arrows. And then I could just hit copy, put it up here, put in a new line and paste it up there and include that. Then I could test it down here and do LeBron. This is like, did you guys ever see those videos that somebody made of LeBron and Steph Curry and Kyrie as babies? This is like baby Jared and baby LeBron. Anyway, that's a funny video. Has nothing to do with this. So that code works. So then I copy it and paste it up here. It really kind of just depends on what you like to do. I think typing it in here first and then just running it is easier. But everybody has their own way of doing things. If you just type it in the command window and leave it down there, it's really messy. You don't want to type it in down here and then just copy everything and put that in your file, because it won't run. And if you do that for your homework, it won't run. It's not all this stuff is not code. So if I put this up here, turn, paste, and then try to run this thing with all that junk in there, it has an error on line 7, column 8. So I go down here to line 7. Column 8 is 1, 2, 3, 4, 5, 6, and it doesn't know there's nothing out here. So over here in 8, it said, oh, there must be an error. So it doesn't know what to do with it. And it's because that's not proper code. Jared equals spaces is not good code. And the 45 is just, doing nothing and whatever. So, did you have a question? No? Okay. I see movement out of the corner of my eyes and I think, oh, somebody must have a question. So, just know that there are different ways to do that, and some ways are, easier than others for some people, and vice versa. I will generally in this class only type in the command window because I don't have time to be going back and forth all the time. I'm constantly thinking of the next thing and, fixing my code and trying to explain stuff, and I can't do that while I'm explaining and going through things. So now we're into Chapter 2. Let's get started in Chapter 2. I am going to go through almost every example that they do here, and maybe some of the practice exercises as well. There are also some kind of bigger you can almost think of them as projects every once in a while. There's like a page that's all gray like these ones. And these are called examples. And sometimes I'll do the examples. Sometimes I won't. Sometimes I think they're better than they are at other times. Sometimes I'll just kind of walk you through the example so you can see where they use different things we've been learning. But I'm going to go through and do the stuff that they do here so you can see exactly how they're doing it in the book. And then every once in a while, I'm going to add something in to maybe explain something. If you have a question, I might do some more code to explain something. You just do the code that we're doing. If you find something interesting, that's fine. You can go and do something interesting on your own for a few minutes, but try to get back to us as soon as possible so you don't miss something. If you have a question, if you have something interesting about, MATLAB that you learned at the moment, feel free to raise your hand and stop what we're doing. We have plenty of time on Wednesdays. We usually don't have trouble getting through this stuff, so make sure that we make the best use of it as we possibly can. All right, let's actually get started. So we're starting off with simple mathematical commands, and if you've ever done anything math, like on a computer, if you've taken a math class on a computer, or you've entered things into a calculator, you know that every time you're putting math onto a computer kind of thing, you have to use some kind of method for doing things that aren't easy to do, like the square of something, right? 5 squared. Well, there's not a button here that says squared on it on my keyboard. On your calculator, there might be. You might actually have a button that has a little box up above the number or something, so it shows you that that's a superscript and it's going to be squared. If you're in Microsoft Word, if you do 5 and then you do this right here, squared, it will actually make it for you. It actually does that for you in Microsoft Word, I think. It used to. I don't remember. But anyway, this is what we're going to use. This is the Shift 6 button, and it's often called the caret because it supposedly looks like a carrot. I don't know. It doesn't look like a carrot to me. Sometimes it's called the hat because it kind of looks like a hat. I don't know anybody who wears that kind of hat, but whatever you want to call it. It's the squared symbol. So if you put in 5 squared, it will actually do 5 squared for you, 25, right? It even knows how to do things like, -1 squared. But you do have to put the -1 inside of parentheses so that it squares both the negative and the 1. So if you do -1 squared, you get 1. I believe that if you do -1 squared without the parentheses, it will treat those two differently. It gives you -1 because it only squares the 1 there. It doesn't square the negative because it treats the negative and the 1 as two different numbers multiplied together. So just little things that you need to be aware of with MATLAB. Also, it has many other functions that it can do. It has functions like the cosine, and that's the next one that they do. In MATLAB, the cosine is set to use radians. How many of you are familiar with radians measurement? A couple of you, okay. So, if for those of you who are not familiar with radians, it's it's actually it makes more sense than degrees. It's kind of scientifically, naturally. Let's see, where do I go to my? Here we go, up here. It make using radians to measure degrees makes a little more sense naturally because a circle, you know, it has this rotational kind of idea to it. But how do you decide how many things you split that into? Does anybody know how we decided on 360 things to split it into? No?
The first 60 we can do. The basic one is like always 90.
Yeah, but why did we choose the number 90 for this angle? Why did we put the number 90 with that? Was it just kind of that looks like the number 90? It's actually really kind of strange. We took it from the clock. Our clock has 60 marks going around it, right? And that idea came from the Egyptians. The Egyptians used a weird system for counting where instead of counting from 1 to 10 and then 11 to 20 and then 21 to 30 using these tens, they counted in 60s. They counted from 1 to 60 using some weird words and symbols that they used. And then they counted from 1 to 60 again to get to the next 60, which is kind of like 20, except it was actually 120, right? So they used a 60-base system, and so they split everything into 60s. And if you split 60 into 60 pieces, then you get, or into 6 pieces, you get 360. And so it kind of came from that idea. It's a weird reason for doing something, but that's the reason that we split it. We could have split it into 2 pieces and said, you go halfway around, that's one angle, that's angle 1, and the other half is angle 2. And if you go halfway that far, 90 degrees now becomes half a degree. You could have used 2 for your total number of angles. But what we do in radians is we actually use the definition of pi. Pi is calculated when you take the distance around this circle and you divide it by the diameter of the circle, the distance across the circle, right? That's the definition for pi. It's a very natural-based, science-y thing. Pi is the original, constant of the universe. All circles, if you take that circumference and divide by that diameter, you always get pi. Doesn't matter if it's a big circle, small circle, turn it this way, turn it that way, put it all over on Mars. Doesn't matter. It's the same thing if you're measuring it in Brooklyn, New York, or if you're measuring it in Oakland, California, on the other side of the country. Doesn't matter. It's the same all the time. And so what we did is we said, why don't we use that number, pi, to determine how much angle is in a circle? Because it actually turns out that there's 2 times pi angle in the circle. We use 2 pi for this, and we use the radius to deal with it, and we call it radians. We could use pi and the diameter, but 2 pi is the radius is something that is used more in science. So they say this whole thing around here, instead of having 360 little angles, we're going to give it 2 pi angles, which seems strange because what is 2 pi? It's some weird number, right? But we don't think of it as a number. We think of it as fractions of pi. So with the circle, you compare the circle here. If you split this into all the angles that we're used to having, like 90s and 45s and other things like this, when you go 90 degrees, you're going to go pi halves radians. When you go 180 degrees, you go pi radians. All right? You go around to 270, it's pi, it's 3 halves pi radians. And then there are other ones in between. This is pi over 4 radians, and so on and so forth. And for 45 degrees, and so on and so forth. So it's just a new way of doing it, and it's much easier for the math if you're actually doing the math of circles and rotation, to use radians than to use degrees. So if I want to know the cosine of 90 degrees, then I have to convert it to radians, and 90 degrees is pi over 2. And MATLAB knows what pi is, so I can just type in pi, maybe. Oh, I have to, hold on. I have to go back to this. Let's see, how do I get out of this? There we go. All right, now I'm ready. So I go pi, and I divide by 2. MATLAB knows what pi is. Needs to have the parentheses in there. It knows what pi is, so if you divide it by 2, it can actually give you the answer. Nope. What did I do? Oh, yeah, that's right. So what is the answer? 6.1232 e to the minus 17. What is that number? This is actually a scientific notation number. So 6.1232 e to the minus 17 is actually equivalent to, let me write it on here since we have Logan. Dang it, come back, you dumb thing. There we go. Annotate. So this number is actually equal to 6.1232 times 10 to the minus 17. So there's another kind of quirky thing about computers and MATLAB is that they write their scientific numbers differently. And this number is actually very, very close to 0. It's almost equal to 0. And the reason that it doesn't go to 0, because it should, the cosine of 90 degrees is actually 0. And it should go to 0, but it doesn't because MATLAB knows that it's a computer. The pi that MATLAB uses is not the exact number for pi. In fact, no computer knows the exact number of pi. It's an approximation for pi. It's close, but it's not quite exact. So when MATLAB actually calculates calculates the cosine of pi over 2, it gets a number very close to 0, but not quite 0, because pi is not perfect. If you plug this into your calculator does things differently. Your calculator actually doesn't truly calculate pi. Your calculator remembers a method for approximating pi, and it knows that if you put in 90 when you're using degrees, or pi over 2 when you're using radians, it knows to just put 0 there. It just tells it, put 0 there. It doesn't actually calculate it. This one actually calculates it using the pi that it knows. And there are ways to just make that equal to 0 in MATLAB, and we'll learn about those here as we go forward. Also, the precision that it gives you here is determined by something that you can put into MATLAB. You can tell it, well, I like having these 4 digits of precision. I like to have that much information. Or I want less, or I want more. It has different abilities to do that, and you can change those. Let's do what they do. They do the cosine of. I got to turn this off again. It's obnoxious. They do the cosine of. Dang it! There we go. The cosine of just pi, right? That one comes out as -1. When you ask why, well, because there are settings within MATLAB that give you precision. If the precision is, if you have zeros beyond the precision of MATLAB, so if this comes out as -1.0000, it just interprets that as -1. It assumes that everything out there is zeros after that. So there's lots of different things that can come out, and so you have to be aware of them, because if you need to use them in one way or another, then you certainly need to understand how they're created. It doesn't really affect us that much in this class, but if you go forward in engineering using MATLAB more and more, it will affect you more and more. So it's good to be aware of them now. In the practice exercise here, they have lots of different things. You know, they do a 5+2, maybe. Why can't I type here? Let's try. Oh, it's still this thing. I always forget. I have to turn this off. Can I just do that? There we go. Okay, now I got it. 5 plus 2. Got to figure out how to use Zoom. And they do 5 times 2. And the times, of course, is the star, 5 times 2. In MATLAB, the star used to be put up high on here, and some versions may do that. I don't know if it does in the versions you have. The newer versions, they put it right between here, so that's kind of nice. It makes more sense. 5 divided by 2. In the book, it goes up high. You can see that. Here you get that precision again, 5 divided by 2. 3, you can do math that's a little more complicated. 3 plus 2 times, and then we put in our parentheses, right? And inside the parentheses, we do a 4 plus 2. Now, MATLAB understands order of operations, and so should you, right? Because you've all taken math classes. You do the 4 plus 2 first, right? And then you multiply, and then you add, right? So the order of operations is obeyed by MATLAB, and it does that properly. I think so, anyway. 4 plus 2 would be 6 times 2 is 12, plus 3 is 15. So yes, it did it correctly. If we did it the other way, it would be 3 plus 2 times, 3 plus 2 times 4 plus 2, and we would, ignore the parentheses and you get a completely different number. But because it knows order of operations, it doesn't do that. And even if you do something like this, 3 times 2 plus 4 or something like this, it will not add the 2 and the 4 together first. It will multiply first. Or if we do it the other way around, if we do 3 plus 2 times 4, 3, I believe that it recognizes the order of operations. Let's check to see if it does. Can't remember. So in this one, 3 plus 2 times 4, it should multiply 2 plus 4, 2 times 4 first, and it gives you 8 plus 3, which is 11. Right? If you did it the other way, if you did 3 plus 2, that would give you 5 times 4 would be 20, and that would not be correct. So it does recognize order of operations, does them correctly. There is a square root function, looks like this, which pretty much every program in the world uses. Square root of 5, for example. So yeah. Here's an interesting one, 6.3 minus 2.1045. So in this case, we have two numbers with different types of precision. This one only has a precision out to the tenths place. This one has precision out to the one, this is tenths, hundredths, thousandths, 10,000ths, right? 1 10,000ths place. So there's a 5 10,000ths place right there, right? And what it will do is it will assume precision here out to the 10,000ths place and do the math. And then it will give it to you in the 10,000ths place. Okay, so I'm going to teach you a little trick here, a little tip and trick of MATLAB. If you're in your command window, which is where you type these things and hit enter and it just goes, right? If you're in the command window, you can actually hit the up button and you can see a list of all your previous commands. And then you can enter them in again. So if I want to do the cosine of pi over 2 again, I go to there and I hit enter and it runs it again. And that's really useful if you're doing something more complex in your command window, because you can do multiple lines of code in your command window and then run them all at once. And if you don't want to type multiple lines in again, you can just, go up with your arrow, your up arrow, and find that line again. So that's useful. Another useful thing about when you're in the command window is if you want to clear your command window out of all the stuff you've put in it, you do clear command, which is CLC. And it just clears everything out. You're done to go, ready to go. Nice clean slate. It doesn't clear your previous commands so that you can still look for previous commands. Just clears your window. There is a command history window that I've never used. Let's see if we can find it here. I don't know where it is. You can actually add windows to this environment. You can add all kinds of different tiles to this environment. And Let's see, I'm not seeing the command history part of this. It might be in the preferences. Let's look there really quick. So, yeah, command history. So if I hit command history here, show, don't show, save exit, don't. This doesn't tell us how we can show it anywhere. Let's go to the, let's see, toolbar grabs, help guide, general. Yeah, I'm not sure how to add that. I believe that there is a way to do it. I've just never done it, and I didn't really ever think about it. But I believe there's a way that you can open up a little window that maybe you put right here or over here. Got plenty of room for windows in here, where you can show your command history. If you're interested in doing that, you can Google it or something. We won't take the time to do it here, but it can be useful, especially when you're doing pretty heavy duty code. Let's see, what else do they talk about here? So now they want to assign variables, which we've already done, right? Do you need to remember the password to that? It's right. Oh, that one actually doesn't have MATLAB loaded onto it. Sorry. Do you have your own computer with you today at all? No. Okay. See, so you're using the laptop? Yeah. So why don't you go over back there and use that one? It's got MATLAB on it. If you're okay. Thank you. Jason, right?
Yeah.
Right. I'll slowly learn everybody's name, but I will also forget everybody's name a lot. So, let's see. So remember that assigning a variable is very simple in MATLAB. The code goes like this. You give the variable a name, whatever you want that name to be. Let's call it, I had my grandson visiting me this break, and he called me Buttons, because every time I sat down to work on things on my computer, he'd come over and want to push the buttons, and he'd say buttons. So he'd sit with me and push buttons. So buttons is going to equal 2 because he's almost 2. I've assigned the variable that I've called buttons, and I've given it I've given a value of 2, right? And if I hit return, it shows up in the command window, buttons equals 2, but also it shows up over here in my workspace, buttons 2, right? I can even double click over here in my workspace and it will open up the variable explorer, they call it. The variable explorer shows you the variable, what the variable is. And it shows you in a kind of like an Excel file looking thing, like a chart, where it puts 2 up here in this first thing. And the reason for that is because MATLAB stands for Matrix Laboratory. MATLAB is designed to do mathematics with matrices, and a matrix is an array of numbers rather than just a single number. And that's really the power of MATLAB. If you can create a matrix of numbers and then do math with it, it's like doing 100 math problems all at once with one command. And while you're in this Matrix Explorer, you can actually add things to this. We could put 3, 4, 5. We could put 3, 4, 5. And if you don't fill in things out here in this field, it automatically puts in zeros. Because when you build an array, it has to be filled with something. An array is essentially this matrix or this chart of numbers, and it has a certain number of columns, a certain number of rows, and all the cells or all the individual parts, elements of this array have to have something in it. So if I save this, if I go ahead and close this array, now buttons is a different thing. Over here, it's called a 4x4 double. That means it has 4 rows. Rows come first, 4 columns, and double means that the numbers have a double precision to them, which means they've got those the digits out there that are 4 digits. So each one of these is saved out to essentially 4 digits. Double meaning so when you're dealing with numbers, you're dealing with these digital groups of ones and zeros. When you have a double array, it uses 2 groups of those numbers, 2 bits. Every number uses 2 bits, and that's why it's a double. You can have a single, which is less precision. You can even have a triple or a quadruple. Okay, so that's how you save variables to an array. That's how you can edit variables over here. You can also change the variable. If I call buttons again, right here, if I call buttons now, it shows it as an array. See, it comes out in this array with rows and columns. And I can actually change buttons. If I say buttons equals 2 again and hit return, it changes it back up here. If I click on the variable explorer, it goes back to being what it was before. And if I call it again, if I type it in here again and hit enter, it just becomes 2 again. That's quite important in programming. The reason it's important is because when you're writing a program and you're making these variables, you're making arrays or just variables that you can use, whatever they are. If you remake that array on accident because you forgot it was named that, you can really mess up your program. If buttons is supposed to be 36 and then you reassign it to be -2 and you didn't realize you've done it because you didn't know that you'd used buttons twice, then it can really mess up your program. So when you're naming your variables, make sure that they're named something that makes sense in the program. For example, let's calculate the area of a triangle. No, let's calculate the area of a rectangle because that's simpler. So we're going to have the area of a rectangle. We're going to have the long side called long side. And that's going to equal 21. And I'm going to hit enter. And then I'm going to have the short side called short side. And that's going to equal 4. Those make sense. Long side, short side. There's no way that I'm going to make like a circle with a radius called short side because it just wouldn't make any sense. The circle doesn't have a short side. And so it's not likely that I'm going to mistake this variable for some other variable in my program. It's not likely that I'm going to use it in a weird place because I've named it in a way that makes sense. And you'll get the hang of this as we do more and more complex programs. And then I can say area equals long side underscore side times short side. All right? Hit enter. And it turns out that 21 times 4 is 84. Ta-da, we've done it, right? So naming variables is important. Many programmers are lazy about that. Many programmers will just call their variables A, B, X, Y, Z, and everything else. And it's fine for them because they're these kinds of peoples that plug themselves into their computer in the morning and they never see the sun and they're all pasty white and they look like vampires. And, they don't interact with human beings. And so if they call somebody X, it doesn't matter. But for the rest of us human beings, we want to be able to know what we've done when we come back to it. So even though it takes longer to write short side than it does to write X, it's a good idea. Another really great idea is to comment in your code what that is. So I'm going to open a script file and show you what that looks like. So long underscore side is going to equal 21, and it's not going to be long side, it's going to be long side. That's going to equal 21, and now I'm going to put, and I like to put spaces around all my operators just because it makes the code cleaner and easier to read. Then I'm going to put a few spaces here, and I'm going to put this hash, is it hash? No, it's not hashtag. It's a % sign. It's different in every piece of code, so I have to remember. Put a % sign there. I'm going to say this is the long side of the rectangle. We're not using a triangle. Rectangle, right? And what this does is it gives you a place to write some text that's not going to be read by MATLAB. MATLAB does not read that. Anything that comes after a % sign on any given line is not going to be read. If I forget that % sign, it starts to read it right away because it's looking at all these things and it's saying, wait a second, I don't understand these things. And because whenever it highlights the words, it either doesn't understand or it thinks it means something that you don't think it means. Another way to comment is you can right click and you could go down here and hit comment, or you can highlight and right click and hit comment. Another great thing is if you need to do multiple lines of comment, so you just got to explain something that's really got a long explanation in it, and you're doing it maybe down here below your first line, and you put in this long explanation, and there's, paragraph after paragraph after paragraph. Maybe you've got a list of things like 1, 2, 1. It does this first, and this can happen in code all the time. Then it does this second or whatever else, and this third. Then you can go ahead and highlight this whole mess, and you can say, highlight this whole mess and say comment, and it'll comment every single line. You can even comment it twice, and it'll put an extra one in there, and that just kind of sets it apart more so you can really see it. And every time it comments, it changes it to green. So, and then when you go to run this code, it does not run the actual comments. I actually pasted it in there on accident. But if you run this code, it doesn't run the comments at all. It just runs the code. So that would, commenting, naming your variables, those kinds of things fall under the style of your code. People that have good style in their code have variables that are long enough to explain the variable, but not so long that it's just like crazy, this variable that's huge. Like there's totally both ends of that. You have these programmers that think they just need to write this variable does this, underscore, 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 and it's like, who knows, 58 characters long, and then that equals 2. You're like, what the heck? Just call it 2, 2 TWO equals 2 or something. But some people like go overboard with that, and some people just go way underboard. And it's actually not very many people that are in between, but it's much easier to read the code of the people in between. So find a nice happy middle there. It'll make you happy. It'll make me happy. And nothing's better than a happy teacher when they're grading your code. So, all right. So let's make some more variables. Let's make some bigger variables. Let's make what we call a vector variable. A vector is it's a type of array. So we're going to call it B like they do in the book. We're on page 14 in case you're trying to keep up there. Also remember that you should be writing code while we're doing this so that you have something to turn into your homework for the participation grade. You should open up your script like this and write the code in there and run it every once in a while, see if it's working. Write what I'm writing. Did you have a question?
Yeah, how do I
Copy and paste from where?
like say I wanted to copy from the command line?
So if you want to put it from the command line from the command window into your editor, then go to the actual piece of code. So here's my piece of code, B equals 9. And then I run that. And then you're going to grab this piece of code that's next to these little arrow thingies. You just hit, you can either right click, and with that computer, it's 2-finger click, and it'll give you the option to copy. Or you can hold down this button, the command button, and the copy and the C, and that'll copy it. Command copy. It's not control copy like on Windows. It's command copy. And then command paste. So I can do command copy, command paste, and it's there. All right. So now let's actually reassign B. Let's make B equal to an array of numbers, or what we're going to call a vector. And this is page 14. They do just 1, 2, 3, 4. So they're going to do 1. Oops, that's 2. They're going to do 1, 2, 3, 4. And again, some people will just do it like this. Some people will like to put spaces after their commas. Yeah, like that. Just to spread things out and make it clean. And what this is going to do is it's going to create an array that has 1 row and 4 columns. This is a 1x4 array. If we look up here at B and we open it up, let's close this thing first. Don't save. So if we open up, why can't I open up? There we go. If I open up B, it shows it's a 1x4 double. 1 row, 4 columns, and each one of those has double precision. it prints out on the screen as just 1, 2, 3, 4 without the square brackets. The square brackets is what tells MATLAB I'm making an array. The commas tell MATLAB that you're making a new column. But you can also just use spaces. I can do B equals, put in my square brackets, and then I can do 1 space, 2 space, 3 space, 4 space. And that gives me the same thing. So you can use commas or spaces to go to a new column. All right? Here's another thing I can do. A equals, actually, let's do some good programming. So I'm going to call this row, or I'm going to call this row. I'm going to say row equals B. I'm going to reassign the vector B into a vector called row. So now row equals 1, 2, 3, 4. That's a row vector or row array or something like this, right? But now I'm going to make a thing called A. I'm going to let A equal, I'm going to put in my square brackets. I'm going to do 1, and I'm going to do semicolon, 2, semicolon, 3, semicolon, 4. And that gives me 1 column, 4 rows. So this is a 4 by 1 array. And if you open up A up here, you'll see that it's a 4 by 1 double. It's 4 rows, 2, 3, 4, 1 column. And I can also reassign that one, and I can just call it column, right, equals A. And now I have a thing over here called column that is also a 4 by 1 array. These are often called vectors because they only have 1 row or 1 column, and then a bunch of the other thing. So when it's just this kind of one-dimensional array, either a row or a column, we often call them vectors. That's kind of a carryover from physics and engineering. In the math world and in the programming world, sometimes people call any kind of an array a vector, and that's totally fine. It's a totally good definition. It's just you just hear both of those things, so don't be confused. Vector, array, matrix, they all pretty much mean the same thing. So essentially what a vector, an array, a matrix means, literally, is it means an ordered or an organized grouping of something. It doesn't have to be even numbers. You can actually make a matrix of images. You can make an array of cattle if you wanted to, right? You can make a vector of homework problems, anything like that. In fact, how many of you have heard of the movie The Matrix? It's also a book, right? Anybody seen it? It's a good movie. I actually like it. Great kung fu movie. But in The Matrix, what they're talking about in The Matrix is 2 things. First of all, The Matrix is this group of millions and billions of people that are organized into this power array that powers the computers and the machines and the robots of the day. But it's also an organization of code that helps them to live this virtual life that helps them, keeps them alive or whatever. But so that's what, a matrix can mean many things, but in essence, it just means some kind of organization of things. Matrix, array, vector, whatever. All right, so let's see what else. Oh, so let's do another one. We're still on page 14. We're about halfway down now. We're going to make this thing here. C equals my capital C there. And I'm going to make an array. So I'm going to put my square brackets down. I always put my square brackets down first, just so I don't have to do it later. And then I'm going to do 1 space, 2 space, 3 space, 4. And then I'm going to put a semicolon. And then I'm going to do 10 space, 20 space, 30 space, 40 space. And then I'm going to do another semicolon. And notice that if I leave a space in somewhere weird, it's not going to matter, actually. Then I'm going to do another one. I'm going to do 5. Well, actually, let's just do that for now. That's good enough. Just those 2. Then I'm going to hit enter. So now I've made an array that has 2 rows and 4 columns. If I open it up, if I open up C over here, it's 2 by 4, 2 rows, 4 columns. Boom, boom, boom. I've entered in my first row, then my second row. right? And I could even put in a third row. I'm going to go back to that command, and I'm going to add in a third row. So I'm going to make it equal to 5 space 10 space 15 space 20 and hit return. So now I have a 3x4 array, 3 rows, 4 columns. And I could even modify it again. I go back to that command line, and I put in another semicolon, and I'm going to call it 110. No, let's do 111. Why not? 112, 113, 114. Don't even have to be in order. It could be skip to 119 if we want to, right? And you're making arrays. You're making matrices. Pretty simple stuff.
So, if we use the spaces, what would the point of the commas be?
The commas and the spaces do the same thing. Yeah, so if you like doing it with commas, do it with commas. If you don't like pressing more buttons than you have to, do it with spaces, right? Which is what most people do. Some people are really good typists, and they just know where the comma is, and so it doesn't make any difference. They just put a comma, the next number, comma, the next number, comma, the next number. I'm not a very good typist, so I always know where the space bar is, but I always forget where the comma is. I can't remember it's comma or a period or like M or something like this, right? And so I don't do that. I just use a space bar because I know where it is all the time. It's just up to you, really. Some people always make their arrays over here. Some people always open up this thing and then build the array in this matrix, and that's fine too. That works. Whatever works for you, it's fine. Got all kinds of options. There are many other ways to make arrays that we will learn about later. And so you can make an array of like a gazillion, cells. Each one of these things inside the array is sometimes called a cell, like in Excel, the program Excel. But it's also, each one is also called an element in MATLAB, which is probably more common in programming. This is an element of an array. This is the element of an array, and this is the element in the first row, the first column. So this is often called element 1, 1. And this one is called element 1, 2, element 1, 3, for example. And in fact, you can even call those elements. If I call the element, if I call C here, whenever you write down a variable and hit enter, or use it, something like that, we call that calling the variable. So we're asking the program to show us that variable. But I can actually put in here C11. 1. I put 1, comma 1. In this case, it requires the comma. And then I can actually hit return, and it tells me what that element is. And then I can do C1, comma 4, and it'll tell me what that element is. Or I can do C4, comma 4, and it tells me what that one is. And I can even do math with that. I can do C4, comma 4 plus 5, for example, and it will give me an answer. I can even replace that element. I can say C4, comma 4 now equals 89. If I plug that in, then it actually rewrites the vector C, or the matrix C, and it replaces that last element with 89 instead of 119. So, and we'll learn more about this later, but MATLAB has this really great way of building these vectors and manipulating these vectors. You wouldn't believe how difficult that can be in some programs. Doing math like this can be much more difficult, particularly when you get into more complex math. That's pretty simple stuff and is not terribly difficult in any program. But if you wanted to multiply two, so for example, if you want to take an entire matrix and multiply everything in that matrix times something and subtract something and do other things, very easy in MATLAB, much harder in many programs. All right, now. Let's see, they're talking about here on page 15, they talk about the document window for a little while, which is essentially, we already talked about, that's over here, where your current folder is. This is essentially the place where your documents are coming from, and this is where your documents are. Well, this is not where the documents are because I don't have one open. But if I opened up a new script, then I would get a document up here, right? Right now, this is a variable. It's not considered a document yet until I write it. And I can save this variable using MATLAB. We'll learn how to do that later. But I could save this variable, and I would actually save it over here on the hard drive. so that I could use it later if it's some really big thing that I don't want to forget. I don't want to have to redo. Then I can save variables over here. I can save all kinds of things. In fact, pictures, photographs, like a JPEG image that you get from your phone when you're taking a camera picture, a JPEG is nothing more than a really complex array. Not super complex, but it's fairly complex. It has rows and columns, and each row and column represents a pixel on your camera. But since your camera has 3 pixels for every pixel, because it has a red, green, and a blue pixel, so you can have color pictures, there's actually not just rows and columns, but there's also another layer behind that of another matrix with rows and columns. So there's a row, if your camera is a 2000 by 2000 pixel camera, then there's a 2000 by 2000 pixel array for red. There's a 2000 by 2000 pixel array for green, and a 2000 by 2000 pixel array for red. Wait, red, green, blue, whatever it was. And all those arrays are in the same matrix. And each cell in that array, each array tells you how bright that pixel should be. And you put all that together, all that information together, gives you an image. It's that simple. So it's just it's a 3-dimensional array of numbers. It has rows, columns, and layers. We call them rows, columns, and drawers, I think, in MATLAB or something. But it doesn't matter. Rows, columns, and layers is fine. And that's what you're saving when you save a picture on your phone. And you can actually open up that file in MATLAB and look at the numbers. You can actually see the numbers there. When the number is 0, that pixel is black. When the number is, well, it's actually white. But when the number is, at the highest it can be, it's at the brightest green or the brightest blue or the brightest red. So. All right. Let's see here. So let's do our first kind of fancy thing here. What time is it? 2:15. Yeah, let's do our first fancy thing here, and then we'll take a little bit of a break. So let's plot something. Plotting things is fun. Let's see, what kind of vectors do we have here so far? Let's make some new vectors. I'm going to go ahead and clear out my command window, CLC. And I'm also going to do this thing. I'm going to close all. No, that's not what I want to do. I'm going to clear all. Clear all. There we go. Clear all is a command that will clear my workspace. It essentially erases all the variables that I was saving in my RAM. And it's a good thing to do when you start programming in MATLAB every day, to clear any variables that you had saved before, because if you didn't turn off your computer and you didn't turn off MATLAB, those things will just be sitting there in your workspace. And if you go to do something and you use one of those variables again, but it's not what you think it's going to be, then it can be a little confusing. So whenever I start MATLAB, I usually clear everything by doing a clear all command. And I often put that at the beginning of my my script as well. So if I've got a script here that I'm running, I might just put at the very beginning, clear all. That way, when I run this script, anything that's already running in MATLAB just gets erased and it starts fresh with my script. It's a useful thing to do. By the way, if I tell you one of these tricks in the room, you can't use it on the MATLAB tips and tricks unless you've already done it. So if you use it before I do, that's fine. But if I use it first, it's not fair game anymore, unless you find something new about it. There's actually a lot of new things about these little tips and tricks that you can discover, new ways to use them. Okay, so let's create two vectors. We're going to create an x vector. X equals, put our little box here, we're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Very simple vector. Entered in. We're going to do a y equals, and this one is going to be 10, 20, 30, 40. Yeah, 10, 20, 30, 40, and 50. Simple. Now I'm going to use a very simple command. Plot. You put parentheses. Whenever you're using a command in MATLAB or a function in MATLAB that's built into MATLAB, it almost always requires that you plug in some kind of something into it. And those are called parameters or whatever. but you put those into parentheses almost always. So we're going to plot here x comma y and hit return. And there we have it. It opens up this new window and it shows you the x. The first thing that you plugged into the plot command is on the horizontal axis. So x is on the horizontal axis. The second thing that you plug in ends up on the vertical axis, and there you go. You can also put this window into your environment here by using this little arrow here. This little arrow will pin this into the environment right there, or you can move it somewhere else. You could actually move it over here. I usually like my plots to be like, see if I can figure out how to make it go down here. There we go. So now I have my figure, my plot right there, and I'm going to switch places and put it down here. Maybe. No, maybe not. Just leave it there. But I can actually change this. I'm going to make my workspace a little bit bigger, my plot a little bit smaller, just because I like it that way. You can do it any way you want. And that way, every time I plot something, it'll just pop in right here instead of jumping out and covering up my little work area. And if you can find me a program that plots quicker and easier than that, you'll be amazing, because that's a really easy way to plot something. Most programs make it a little harder for you, and some of them make it a lot harder. Very simple though. You do have to have matching vectors here. If I change vector x to be something else, let's say that I go here to x and I open it up and I say, well, I want one more number on there. Let's make this equal to 6. And then I close that up really quick, and here we go. And then I go back here and I plot xy again. It does not like that. Vectors must be the same length. It has to have a number to match with every number. So then I go to y, I open up y maybe, and I'm going to add something onto the end of this. I'm going to add 200 onto the end of that. Close that up. And I'm going to do it again. Plot xy. Oops. Oh yeah, it worked. So here we go. We have that first plot that went from 1 to 5, and then 6, it jumps up to 200. So there's our plot. All right. So that takes us almost halfway through our class today. So we're going to take a little bit of a break. Go ahead and get up, use the bathroom, get a drink. I actually have a bunch of drinks on this card out here if you want some. You can grab a water bottle or a juice even. And we'll come back here in 5-10 minutes. We'll come back at 1:30. Is that 1? What the heck is that time? 2:30. 2:30. We'll come back at 2:30 and we will continue on with this. Oh.
Jared. This is Tammy from Bureau Wireless, and
Sorry. Had to check a message. All right. Okay, let's let's get on with the rest of chapter 2 here. Excuse me. We've got a few things to get through. It's not actually as much as it looks like. We're on page 19 and the chapter goes all the way to page like 52 or something. But a lot of that is these big examples that we probably will not go into in great detail. So let's go ahead and move to page 18. On page 18, we are learning about variable names. Because MATLAB has a lot of functions involved with it and a lot of built-in things that it recognizes. For example, we just used the function plot. But if I tried to assign plot to be a number, plot equals 5 or something like this, I can do it. But that's going to confuse MATLAB. Because now MATLAB, when I write plot something, it's going to think, well, does it mean the variable? Because it knows that the variable plot equals 5. Or does it mean the function I'm supposed to be plotting something, right? And so that can be confusing to MATLAB. And so you don't want to do that if you can help it. Sometimes you do it, sometimes it's necessary. There aren't many times when that is necessary, but sometimes it kind of is. But you want to avoid it whenever possible. So there are also some variable names that are just not allowed at all. So if I do something like, let's do this forever equals a big number, right? It does not like that, right? The reason is because you're not allowed to start a variable name with a number. It's just not allowed. So other things that you can't do, for example, you can't start with any kind of, I don't think you can do that either. Yeah, you can't do that. Like you can't use any of the symbols. You can use the symbols in your variables, like if we did for and ever. No, it won't let me do that. But if I did for and ever, it might. For and ever equals 56. Nope, won't let me do that even. Can't. Can't do it. And the reason for this, again, is that there are certain things that it recognizes. It recognizes for example. FOR is something that we will use in MATLAB. And so it has for is not a function, but it's a recognized operator in MATLAB. It does something, it means something to MATLAB. We'll learn about that. And also means something, this ampersand is what it's called. This is called an ampersand, but if you type that into MATLAB, it actually has a meaning for that. It has a meaning for a lot of different things. If we did with, well, not with, apparently. Let's do else. It has a meaning for that, and it highlights it in blue. So there's lots of things, and I don't think I can assign anything to else. Let's try it. Sheesh. Else equals 45. Yeah, so it won't even allow me to use that because they call it a keyword, because when you use it with other things, it essentially activates an action within MATLAB. It's not quite the same as a function. A function is something that you plug something into and it spits something out, whereas in these keywords means something within a larger context and within a larger program. And we'll learn a lot about those keywords as we learn more about programming. There is actually a list of keywords in MATLAB, and it's on page 18, and you can actually get it in your MATLAB. You just say is keyword, all one word, and that brings up a list of keywords that you cannot use in MATLAB. So break, case, catch, class def, continue, else, else if, and, for, function, global, if, otherwise, par for, persistent return, SPMD, switch, try, while. And there are even more if you add different components to MATLAB. Like there are different tools that you can add to MATLAB for doing like artificial intelligence work or something like this. And then that very well could add more keywords. And those you're not allowed to use. You can also test a variable name. So let's say that, well, let's say that Logan out there in McCook wants to do a keyword. He wants to say Logan dash McCook, like that. And you can see that it doesn't, but you could also just check it and call and say this, is var name, that's a function, but this function doesn't require you to use parentheses. Then you can just say Logan dash MCC, and it'll give you an answer. The answer is always in logical form. It's either a 1 or a 0. 1 means yes, good, go for it, positive, right? 0 means no. So you cannot use Logan dash MCC as a variable name in MATLAB, which we already knew because we tried it. You can also do, let's see, there's another one that I was thinking of that I can't remember now. Well, and the reason you can't do Logan dash MPCC is because it doesn't allow the dash. You could do the same thing and do an underscore. Underscores are allowed. So then we hit that and it allows it, says 1, we're good to go. So that can be a variable name. So the reason that we show you this is because every once in a while when you're in MATLAB, you're writing some code and something goes wrong, you're not sure what went wrong because you've used something in MATLAB and assigned a variable to it that wasn't allowed, but it still allowed the code to run because it interpreted it differently than you interpreted it. So it used that word to do something differently than you thought you were assigning a variable, but it did something else. And so it's often a good idea to check your variable names if you're not sure. Eventually you just kind of get a feel for it and it's not really that hard to do. Yeah. If you ever do assign something that you shouldn't, what was the one that I assigned earlier? Plot. So I said plot equals 4, right? It's not 4 anymore because I cleared it out of the workspace. But let's say I say plot equals 4, right? Now I've got that. that thing and I try to do a plot here and it returns 4 instead, I can actually clear just that variable, I believe. Let's see, don't they do it here somewhere? Yeah, I can just do clear. So I usually do clear all, but you can also just clear plot. And now that variable is no longer in your workspace. It just erased that. You can clear any variable. So if you don't assign something a variable and it outputs a number, it just calls it answer. So the last thing that MATLAB outputted before plot was this 1. So answer was equal to 1. And I can clear the answer as well. And that brings up an interesting point, because if I do any math, like 8 times 9 in MATLAB, it assigns the variable answer, ANS, to that latest thing, because I didn't give it a name. I can actually say that M equals, for example, M equals 8 times 9, and then it applies that assignment. M is now equal to 8 times 9, which is 72. But answer is also equal to 72 because I did that math earlier. And I can actually take that answer, ANS, and multiply it by my M and get the value, which is 72 times 72. But now it has reassigned answer to this latest value. That answer is no longer equal to 72. So answer is kind of this running variable that pops up whenever you type in a calculation into MATLAB and you don't assign it to a variable. So it's saved until the next time you do that, and it's over there in your workspace. All right, moving on. Let's go out to, so now we're going to go on to some more stuff with matrices. We've already done some of this stuff, but let's do some more. Let's make a matrix. We're going to make a matrix A. That's not very exciting. Let's do the matrix. We already did all this. We did order of operations. We did scalar operations. We built some matrices. We did some area. We did some calculations. That's fine. We got a little ahead of ourselves. I often do that. I often skip ahead to things because it seems like it's going to go well in that spot, and then we have to skip it later. We've done everything up to page 23. Here's a function we haven't encountered yet, the exponential. The exponential of, for example, 5, right? Exponential of 5. This exponential function is the natural exponent. Anybody aware of what the natural exponent is? Yeah, it's that script e to the something, right? That script e comes from a statistical analysis kind of thing. And it's the reason it's called the natural exponent is because it is when you're doing the statistical, I guess statistical analysis is not the best way to describe it, but it is a way to describe it. But anyway, it has to do with a number that comes out of a particular mathematical thing that we do in science. And it always comes out this kind of same way, or it often does. And so they decided to assign this mathematical thing to a number because it always comes out with the same number. And this number happens to be, let's actually just do it right here. That number right there, 2.7183, and it has a whole bunch of other digits. It's kind of like pi, actually. Pi comes out when we take the circumference of the circle and divide by the diameter. I always forget that word. Divide by the diameter, and you get this number, 3.141596, all this stuff, and it keeps going forever and ever. And we get a similar thing when we do this decay rate thing in some statistical analysis in nature, and this number comes out. And it has to do with the way things grow and the way things die. So when, like, for example, if you're looking at aphids or mosquitoes or something, the way that they grow has to do with this process of them meeting and mating and then creating more eggs. And then those eggs, some of those eggs live, some of them don't. And then those eggs meet and it has this curve that kind of climbs up like crazy. And then when mosquitoes die, the same curve happens, and or weeds or something like this. So it has to do with growth curves and decay curves and everything else. And it works for mosquitoes, and it also works for like nuclear radioactive material. When radioactive material becomes less radioactive over time, it follows the same kind of curve. And so it works in all parts of nature. It's kind of weird, but this number always pops up. And so, and it's a little more sublime than that, but we don't have time to really get into it. But the idea is that we want to have that available to us because it's so commonly used. So we have a function for it, the exponent, and it has many more digits than this in MATLAB. MATLAB has stored many more digits than that, and you can ask for more precision, but that's the number. And so we can use that. That's another function we can use, and they show that one. We can also do logarithms, and we can do all kinds of things. We can, let's see, what are they doing here? Here they're calculating. I don't actually know what they're doing here. What are they doing here? That's, oh, I see. Here they do something kind of interesting that many people think you should be able to do. So they're going to build a polynomial, and first they're going to set some values. They're going to say that, let's say that a equals 3, and let's say that b equals 4 and c equals 1 or something like this, whatever. B equals 4, c equals 1. So now I've got this a, b, and c thing, these a, b, and c numbers. And then I might want to do something like this. Polynomial, or just call it poly, equals a times x squared minus b times x minus c or something, you know, and build a polynomial. The problem is MATLAB doesn't know what x is. MATLAB doesn't really deal with unassigned variables very well on its own. There is an add-on to MATLAB that can deal with unassigned variables, but we don't deal with it. We don't teach it in this class. It's actually called Simulink, and I don't remember if they cover it in this book. I think that they do, but I skip it. Mostly I skip it because I don't want students to use MATLAB in their very first year of college to cheat on their tests in, you know, where you have some crazy algebra problem. And I just don't think that's a good idea, because you need to learn how to do algebra in order to actually be able to, you know, function in the science world or the engineering world. So, so I don't teach it for that reason. I also don't teach it because I never learned it, and when I did try to learn it, it was a bit confusing to me. And I don't know if that's changed over the past 10 years since I looked at it last, but maybe it's gotten better. It probably has. There are actually many programs that will do algebra for you, that will accept, you know, unassigned variables. You can have an x squared in there, and it will solve for x squared. Many programs that will do that. But are they very useful? They have their uses. Usually they're useful to people who have been through all the math and understand it all, so they don't make mistakes using it. For somebody that's just kind of starting their career, I don't think it's as useful. I think it actually can cause more trouble than it solves. So, so MATLAB can't do it just on its own. It has to have an add-on to do that. We're not going to learn it. So if you want this to mean anything here, we need to assign x to be something. So maybe we say x equals 7, assign that, and then we go back and say poly equals this, and we get an answer. So it can evaluate a polynomial, but it can't solve a polynomial, at least not easily. You can solve a polynomial using MATLAB. It's just, it's much more complicated and it just becomes not worth it unless the polynomial is like impossible. There are plenty of polynomials that are impossible to solve that you need a computer to do, but you generally don't encounter them until you're, you know, a high-end engineering student, high-end math student, or a high-end physics student. Those are the only people that ever encounter those kinds of things. High-end computer science students also do that, but there are not many students in a school that ever encounter that, so don't mess with it too much. I'm going to skip this first big example, 2.1. If you look through it, they're just plugging numbers into a formula and solving for other numbers, you know, by rearranging the formula and plugging the numbers they know in. It's not terribly difficult. It's no different than the things we've done so far in these examples. So I want to move on to 27, page 27, where we start working with arrays and what you can do to arrays. They call this array operations. So this starts to become the different ways you can build arrays, the different ways you can manipulate arrays, so on and so forth. Now, here's another thing. If you have a figure window open, you can actually close all, and it'll close that figure window. So let's go, we're on page 27. They build some different vectors really quick. They build a row vector and a column vector, and that's great. And then they build an array, a 3x4 array it looks like, and that's just like we've done before. And then they start to do these things a little bit differently. So on about a third of the way down page 28, we're going to do this. B equals, and we're going to do a 1, and then we're going to do a colon, then we're going to do a 5. Hit enter. And look what it does. That's a really quick way to build an array, isn't it? What the colon operator does. So the colon is an operator in MATLAB that specifically does something. And in this particular case, it takes these two integers. If a colon is separated, but if a colon separates two integers, actually I think they have to be positive integers. I don't know if you can do it with negative numbers. Let's try. Maybe you can. Let's go from. I'm betting that you actually can. So let's see if you can. You can. Look at that. So it can be integers. What it does is it creates an array that goes from the first integer to the second integer in integer steps. So just boom, 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 one step at a time. Let's try some other things with it and see if it works. Let's try to go from 5.5 to 5 and see if it gives us something. It does. So it doesn't even have to start at an integer, but notice that it ends before it hits the final integer, right? So it can go up to 5, but it can't go over 5. So it doesn't go to 5.5. It goes from 5.5 in integer steps all the way to the point where it's right before it hits 5, and then it stops, right? So it can do that. There's another thing that it can do, which is this. We can start at -5, and we can go to 5, but we can also put another colon in here and put a number in between. And then when we do this, the number in between tells us how big of a step we're going to take in between these two numbers. So if I take a step of 0.1, 0.1, actually let's just do 1. If I do a step of 1, then it gives me that first array that went from -5 to 5. But if I go from 0.1, and I like to write the 0.1 in there. You don't have to. You don't have to put the 0, but I like to because it's easier to see, easier to read. But that's going to give us an array that's much bigger, right? It's going to go in steps of 1/10. So it goes -5, then -4.9, then -4.8, then -4.7, all the way up to 5, right? And you can even do this. I'm going to go from -5 to 5, and I'm going to do it in steps of 10. What do you think that's going to give me? It's going to be give me -5 and 5, and that's it, right? So this is a very quick way to build arrays of numbers that are in sequence, right? One after the other, evenly spaced, a very nice arithmetic sequence of numbers. You're just adding a little bit to the next one, adding a little bit to the next one. So it's a very quick way to do that. In fact, we can do it. Well, actually, let's try to do it. I think I remember how to do this. Let's try it. We can go. We can let's see. I don't think I'm remembering how to do this right. I'm going to just try this but I'm pretty sure it's not right. Pretty sure this will not work. There is a way to do it. I'm just not remembering it. We'll get to it eventually, though. Oh, it did do it. Okay. So what this one did is it gave me a row from -5 to 5, and then another row from -5 to 5, right? And I could even do more rows. I could do one from -1 to 1. Can anybody see my problem here? Let's go from -2 to 2. Is this going to work? No, because what it tried to do is in the 3 row, it tried to do -2 to 1, -1, 0, 1, 2, and that only has 5 elements in it, but it wants 10 elements, right? And so I actually have to give something with 10 elements in here from -2 to 2. So to do that properly, I have to create this so it has 10 elements, and I'm going to step it in 0.2. In size of 0.2, we'll give it 10 elements, and then, not quite, apparently, -2 by, that should have been right. Oh, it's not 10 elements, it's 11 elements. It's 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Let's see what this does for me if I go from -2 by 0.2 to 2. That gives me 21 elements. I don't want 21, so I need to go by 0.4, I think. Yeah. I need half as many. So that gives me 11 elements. So if I change this one to by 0.4, there you go. And that shows you another thing to do in MATLAB is if something doesn't come out right, just try it on its own and see what happens, and then you try to adjust it, right? I saw that it wasn't working here, obviously, so I just took out this little piece and I ran it on its own to see what's happening. Notice that it's giving me twice as many as I need. So I went ahead and I made the step bigger so I would have half as many, roughly, and then I was able to do it. And now if we open up B, we see that we've got this 3 by 11 array that we've built using one command, right? Did you have a question? No, good.
Just look, so look for -2 and 0.4 and 2. So for me, for some reason, it doesn't work.
So this piece of code right here didn't work for you?
Yeah.
So -5:5 semicolon, -5:5 semicolon. This one is -2.
I know where.
Yeah, okay. Oftentimes when you're to the semicolon,
Instead of semicolon.
yeah. So yeah, you got to make sure that it's semicolon or colon where it needs to be. Very easy to miss that. So again, some people like to put spaces in here just to make it a little easy. Ooh. Oh, I must have cleared it out. I'm going to copy this. I'm going to paste it down here. So some people like to space this out a little bit more. Some people will put spaces everywhere, like here, here, even here, here. I definitely don't do that many spaces because I find that confusing. But I might, if I'm feeling like I'm not understanding something or not seeing something, I might put a space between my semicolons. I usually don't put them between my colons because that's, for me, pretty easy to see. It really comes down to what's the most comfortable thing for you to see on your screen, right? And so, and you can run it like that and it'll still run. MATLAB just ignores spaces for the most part. Does that help a little bit? Okay. All right. So I can actually go to full screen mode somewhere here. Right there. That makes it a little bit bigger. All right. I asked for a screen over here too. They didn't give it to me. So, all right. Moving on to other things that we can do, there is a function called the linspace function. So if we call the linspace function, linspace means linear space. So what it does is it creates an array that is linearly spaced between two numbers. What do you mean linearly spaced? It means the steps between those numbers are even. And you just tell it how many steps to take. So if I want to do between the numbers 1 and 10, 1, comma 10, and I want 3 total steps, then I do 1, comma 10, comma 3. And it interprets this as I want to make an array that starts at 1, that ends at 10, and has 3 total elements in it. Hit enter, it gives you 1, 5.5, and 10. And you would think, why doesn't it go 1, 5, 10? Why not? Well, what's the difference between 5 and 1? 5 minus 1 is 4. What's the difference between 10 and 5? 10 minus 5 is 5. So 5 is not exactly in between 1 and 10. 5.5 is exactly between 1 and 10, right? If you did the same linspace and you went between 0 and 10 with 3 numbers, you would get 0, 5, and 10, right? And you can make this linspace as crazy as you want it to be. You can do linspace, and I want to go between negative 34, and I want to go to 3 times pi, and I want to do it in 27 steps. And MATLAB will do it. I cannot tell you how incredibly useful that is when you're doing science. Because so many times when you're doing science, you know the endpoints of something, you know where you're going to start, you know where you're going to end, and you know you want to take a nice equal number of steps in between. But calculating that is majorly painful. It's just a mess. And this one just goes, poof, cranks it out, you're done. Right? So that's a beautiful little function there, the linspace command. And you can assign a variable to linspace. So you can say D equals the linspace of this, hit return, and it assigns it to a variable over here, puts it in an array, and you're good to go. Is that working for everybody? Getting that to go? The linspace command? Any questions on that? How that works? Here's another one. The log space command. Let's actually just use the same numbers. No, let's not. Let's use something a little more. What do they use? Log space. Let's use a better one. Let's go between 0 and 1,000 log space with 5 total numbers. So we're going to call this log space now instead of linspace. How many of you remember what a logarithm is? Whoops, that one didn't work out so well. Let's do theirs after all. I wanted to do something that would look spectacular, but it didn't turn out spectacular. So theirs is log space 133. I got a little crazy. Go. So here they're going from 0 to 3 with 3 elements, but is that really what we're getting? Well, it is actually what we're getting, but it's in a logarithmic sense. So here we have a multiplier out in front. 1 times 10 to the 3 times this number. So what is 1 times 10 to the 3 times 0.001? That happens to be 1. That number is actually 1. Right? And then this one here is 1 times 10 to the 3 times 0.0316, which is actually 31.6. And then this one is actually 1,000. It's 1 times 10 to the 3 times 1, which is 1,000. So what this did is it gave us a number. It gave us 3 numbers going between 3 to the, let's see, it's 10 to the 0. Yeah, so 3 numbers between 10 to the 0 and 10 to the 3. So it's log base 10. So this 0 means 10 to the 0. This 3 means 10 to the 3. So 10 to the 0 is the first number, which is 1. 10 to the 3 is the last number, which is 1,000. And the one that's in between is evenly spaced logarithmically between the two. What does evenly spaced logarithmically mean? It means that if you plotted this thing on a logarithmic scale, the line would be straight. That's probably the best explanation for it. If you think of it in terms of what's in the exponent, it means that the thing that it's in the exponent is let's see. I think that means it would be evenly spaced between 0 and 1. No, 0 and 3. So this would be 1,000 to the 1.5, I think. Let's check and see if that's true. 1,000 to the 1.5 power. If that's the same as this number, then I've explained that correctly. Yep, it is. So, nope, not quite. To the it's the same digits, but it's not the same multiplier. So I explained it partially well. I'm forgetting something about logarithmic scales. But anyway, that gives you really what you need to know is that it gives you three evenly spaced numbers in logarithm, where this one is 0 and this one is 10 to the 0, or 10 to the 0. This one's 10 to the 3, and this one is the one that's logarithmically spaced in between it. It's kind of goofy the only way I can really remember it is if you do a logarithmic scale on your y-axis and you know a linear scale on your x-axis, then this is going to be a straight line, and that point lies right in between these 2 points. But anyway, not something that we use in this class much for logarithm, but it's something you'll definitely use in science classes later on or math classes later on, and MATLAB can do it. Okay, so now let's do some operations that are more mathematical with actual arrays or matrices. What time is it? 3 o'clock. Are we done at 3 o'clock or 4 o'clock? 3:30. Okay, good. Okay. So let's see. Here we go. Let's do clear all. Let's see. Okay, we're going to start off with some variable, we're going to assign some variables. A is going to equal 1, 2, 3. Oops. Put on my brackets there. So there's my A, and B is going to equal, we're going to call it A plus 5. So when you add a number to an array, this is what it does. It adds it to every element in the array. Okay? Same goes for multiplication. C equals A times 5. Multiplies every element of the array. This is what we call scalar operations on an array. A scalar is just a plain number. An array is a group of numbers. And when you multiply a scalar times an array, everything in the array gets multiplied by it. When you add a scalar to an array, everything in the array gets that number added to it. It's just the way scalar operations go. The same thing goes if you square the array. If you take A squared, everything in the array gets squared by it, but you have to tell it that, everything in the array gets squared, but you have to tell it that you're doing this with an array. So you put a little dot in front of it. So it's A dot squared. What's the difference? Here, it's an array and a scalar. An array and a scalar. Here, it's an array and an array because A squared actually means A times A, right? That's what A squared means. And when you do A times A, just normally, MATLAB doesn't like it because there's different ways that you can multiply arrays together. But if you do A dot squared or A dot times A, then it knows you just want it to multiply the first one times the first one, the second one times the second one, the third one times the third one. It knows that you want to go element by element and multiply them together, and so it allows you to do that. 149 multiplies 1 times 1, which is A times A, the first element, 2 times 2, which is A times A, the second element, 3 times 3, which is A times A, the third element. But you could also do it with B. We could do A dot times B. Remember that B is 6, 7, 8. So if we multiply 1, 2, 3 times 6, 7, 8, we should get 1 times 6, 2 times 7, 3 times 8 if we use the dot times, because dot times mean do it element by element. So you get 6, 14, 24, and it works. So that's what the dot does in front of an operator, in front of a math operator. It just tells MATLAB that you want to do it element by element. But that means that you must have two arrays that are the same size. So if I have an array called D and it equals 3, 4, 5, 6, 7, or so 78, that works too. If I have an array that has 5 elements in it, like this, and I try to do A dot times D, MATLAB does not like it because it multiplies the first elements together, then the second, then the third, and then it gets to the fourth ones, and D has a fourth one, but A doesn't. A only has 3 elements. So the elements, the number of dimensions has to agree. And you can do this with 2 by 2 dimensions and 4 by 3 dimensions. You can do it with arrays that are bigger as well. You can multiply element by element by element. And that's a huge help because it allows you to take a huge group of numbers and multiply by another huge group of numbers, or divide or add or whatever else. Yes?
Can you multiply the arrays without if you don't go
Yes.
element by element?
You can multiply the arrays without the dot, but it's a different kind of multiplication, and it's not just times. It's not just A times B. We use a different function for it, and it's called the cross product. Have you heard of the cross product before? No. Okay, so anybody who's taken like Calc 3 or physics, physics with calculus, you'll learn about a thing called a cross product, or if you've taken linear algebra, which is usually a class you take like junior year or something. The cross product allows you to multiply matrices together in a different way than this type of multiplication. And the reason that it's a different way is mathematically and kind of sciencey related, and you'll learn about it eventually. And it has its own function here. We don't use the times operator. We use a cross product operator. So, it's often called a vector product. So you can do it, but not with that. So. Yeah. So, any other questions about that before we move on? So, in this next example, they do some things using arrays and some calculations using arrays. They actually, take one of the things that you can do, for example, is you have a whole list of students' grades. Maybe everybody's grade on the exam is in one column, and everybody's grade on the homework is in another column. Everybody's grade on the quiz is in another column. You can actually say, okay, I'm going to take another column vector. But you can say, well, the exams are going to be worth 5 times as much as the quizzes, and the homework is going to be worth 2 times as much as the quizzes. So I can take 5 times the homework, 5 times the exams plus, so 5 times the exam scores plus 2 times the homework scores plus 1 times the quiz scores, and then I can create a final grade for everybody doing that. But it doesn't do Joe first, and then Fred, and then Mary, and then Hank, and whoever. It doesn't do it one at a time. MATLAB does all that at once. It's called parallel computing. It can just take all those numbers and just go kaboom and spit it out. And that is so much faster than most programs. Most programs will go through and say, well, let's do Mary's first, and then let's do Joe's, and then and it does it one at a time. And it can take forever. And when you're doing 1 million lines of data like that, which is very common, or even more for a computer, it will just kill your computer. Your computer will just go, the little spinning arrow, the spinning thing or whatever, forever and ever and ever. And back in my day, when we were computing, we didn't have any power on our computers, so we really had to be careful. But even today, with you buy a computer, you just buy just a normal computer out there, you can bog it down with MATLAB in a quick hurry, just like that. Just doing something that's a little too big for it, you're out of luck, right? In order to avoid that, we use programs like MATLAB, and if you use them properly, you can cut down on your calculation time, cut down on the work that the computer is doing, and make it way more efficient, way faster. So all kinds of things can happen. It's a good thing. That's probably the biggest reason that MATLAB was invented, is so that you could do these huge amounts of calculations all at once and just be done. Okay, so on this section here, it starts on page 38. They're talking about different ways to display numbers. They talk about scientific notation. We've already experienced that. They talk about the different levels of numbers of precision. So, for example, if we type in the number 5 here, we can do that, but we can also say format long, and then we can type in 5. Or let's do an answer. Let's do a math problem actually. 5 times 89.4 or something like this, and it gives us this answer. Did I get my format long in there? I didn't actually. Why didn't it change it for me? It should have. Let's do a decimal number. I think that's what it's wanting. So I do 56 point. There we go. So if I do 56.1, anytime you start putting in decimals instead of integers, it starts displaying zeros. If I go back to format short and I display the previous number answer, then it gives me a shorter format, and it'll do all kinds of other formats as well. It has a bank format. It has a short format, bank format. I mean, it has lots of other ones. Short E format, short scientific format. So just so that you can change those formats up and have lots of different ways to put that in there. They even have a ratio format, or a rational format rather, so that you can express fractions. So if you do format rational, format rat, right? Then you can display a like 0.1 becomes 1/10, right? 7. So let's see what 0.7777 gives us. 7/9, right? And so on. As we get here towards the end of the chapter, they talk about saving your work. So we've already talked about that, but just as a review, when you open up a script and you're typing in some code up here or whatever, you don't necessarily, whatever you're typing, you don't necessarily want to drag all this stuff from the command window up here. Just the commands, the things that are next to the little double arrows. That's what you want to put up here. And then you can run it and see if it works. When you run it, it's going to save it. And it'll give you some options sometimes. It'll ask you to pause. It'll ask if you want to pause if there's an error or a warning or anything else like this. You can just run it and not care. That will save it. You can also go up here to save, and it will save it without running it at all, without checking the code, without checking for errors. Then you type in your whatever, and call this for your participation files. You want to put your name on it. So I might put Jared, and I might put underscore chapter 1 or something like this. Chapter 1 participation. Save that, and it's saved now. Pretty simple stuff. Different ways to save it, but it all does the same thing, and that will go to whatever folder is open over here, unless you choose it to go somewhere else. They also have a thing in MATLAB called a diary. I've never really used it, but if you do diary on in your command window here, then it will save all of your work into a file. I don't remember exactly where it saves it, but you can also do so you can actually give it a file name. So if I do diary and I put a file name right after this, Jared underscore chapter 1 like this, then it actually creates a file over here, and it will write everything that I do here. So if I do fun equals 45 or whatever, then I can actually go here, and I think that it should show up in my diary somewhere. I can't remember if I have to end my diary or not. Diary, my diary. Oh yeah, then you have to save it. I don't remember. I don't remember how you save it there, but it saves it over here, and I've never really used it, so I don't remember how it's done. But if you want to use that, you can try it. I'm not going to try to figure it out right now because we're coming towards the end. It's actually frozen my computer. Are you kidding me? That's funny. So apparently if you click on that file, MATLAB really doesn't like it. Did it open yours? It didn't open mine. I don't know what I did wrong. But apparently it's frozen my entire computer. Or maybe something else I did froze it. That's entirely possible. This is actually a good illustration of what can happen if you do something that MATLAB can get stuck in a loop. It can get stuck doing something that takes super long or something that is infinitely long. And it's actually fairly easy to do it. Any program can do this. Even Windows does this all the time. Whenever you get that blue screen in Windows, it's because you did something that made Windows think that it had this process that it needed to keep doing over and over and over again. And it's either stuck in a loop or it gets stuck against a wall somewhere and it's just screwed. You just got to start over again. In Windows, of course, that means your entire life is over and you got to start over. In MATLAB, they actually have a command built in so that you can stop whatever it is you're doing. And I can't remember what it is at the moment. If you want to look it up, you can, and then you can put it in the thing. It's called interrupt, or it's like the interrupt function or the interrupt shortcut key or something like this. And it'll essentially interrupt whatever's happening in MATLAB, and then it'll start you over. In Windows, of course, there are things for doing that. Most people don't know what they are, and most people know how to type things into the terminal anyway. So most people just restart their computer and it just redoes everything. Since I can't remember what that is, I won't do it. But at the end of this chapter, they talk about saving variables. So that there's a save function, there's a load function, and we will get experience using those later. We don't actually have to use them right now, so we won't worry about it. But you can do it, and it will save it to your hard drive section over in your current folder area. And then they talk about scripts, which we've already talked about. So making a script to save your commands and to put that together. So that's all we really need to talk about right now. We will actually talk about these things many, many times throughout the course of the class. You have your homework to go and do. It's not a terribly hard assignment. And we will see you next Wednesday, where we will start Chapter 3. Any other questions before we break for the day? I think it's just very fitting that I crashed my MATLAB at the end of the first day. Reminds me of when Bill Gates has done several launches of Windows over the years, and he's had like 4 or 5 launches where he's like, "This is our great new Windows," and it's crashed immediately. Like as soon as he turns it on, it goes. I'm like, that's hilarious. It hasn't happened as many times to Apple because Apple rewrites their software more often, so they take out a lot of those bugs. But it has happened to Apple. The funniest thing that happened to Apple, though, is when Steve Jobs got up and he was showing his new software. One of the new things in the software was that you could set up your computer to be a virtual hotpoint or whatever for Wi-Fi, right? For being like a Wi-Fi station. And everybody at the conference had set up their computer to be a virtual Wi-Fi station. And so everybody's computer in the entire building was overwhelmed by Wi-Fi signals, and it just confused the heck out of every computer. Like, I think he said, he was looking at his computer and saying, "What's wrong?" And he's like, "There's like 37,000 Wi-Fi hotspots here." It was hilarious. I'm like, that's just too funny. So even the best computer geniuses in the world have problems with crashing computers, and I consider myself honored to be among them. Anyway, have a great day, a great weekend. And if you have any questions, feel free to email me. Make sure that you make use of Google as well. Yes, sir.
So what we did today here and everything, we just need to upload it.
Yeah, so this file that you've made today, this script file, save it as your name, participation, chapter 1 or something like that, and then upload it. You'll go to, let's see if I can't access anything on my computer right now, but you'll go to My Open Math, open up the participation homework, click on the upload file, put that in there, and that's good.
So every line of code we did in the console. basically copy pasting the script and then the script.
Yeah, yeah, essentially. Or write it up in the script to begin with, right? You can just write it in the script and then run it to see if it's working during the day. So those are the two different options. Some people like to just copy everything that they did in the command window and put it in their script. But when you do that, you do have to erase the outputs because the outputs are not code, right? So you can do it either way.
I have a question because most of the time, Professor did like clear screen.
Yeah, when I cleared screen, you cleared screen, and then you're stuck. You don't have that code. Don't worry about it for today. Today is your first day. Today's your first day. So if you erased a bunch of that code, go in and write some code, some of the stuff that you remember. Maybe do 1 page from the book or something, and then just write me a little note and said, I didn't understand the whole thing about the script saving to the script, so I'm done now, and I'll just count that. No big deal. But next week, try to remember, because it's important to try to get used to how a script works. So type it into the script and then run it every once in a while to see if it's working, and then type it into the script or copy it into the script as you go. One or the other, whichever works best for you. And if that script doesn't run perfectly, I don't really care. It's not that important to me because it's just to show that you were here and that you were paying attention, right? So, any other questions? Logan, do you have any questions? Are you still there?